This is a tremendous crowd. We started this 3 years ago. And I think Pam can help me with the numbers. We had maybe 50 that first year, close to 50. Then last year we approached 105. And this year Pam said we had 118 girls sign up. So that's wonderful and that's fantastic to see. And we had to change our location to accommodate everybody. So that's great. So we'd like to thank ABC for donating our memory sticks here. So Jessica's from ABC, so they sponsored this and they donated the gifts. We have a lot of speakers today. We have Chris Jekyll and Beverly King from Cobham, USA. They're going to tell you a little bit about what they do as engineers. Then we have 8 students, current engineering students from various schools that are going to take turns talking to you about what kind of things they've done in engineering school and what they're looking forward to when they're graduating and that kind of thing. So we'll start with Chris and Beverly from Cobham, and we'll go from there.
Guys are mechanical engineers at Cobham. Chris has been there a little over 15 years. I've been there 10 years. If you want to go to the first slide, I'll just give you a little background about our company that we work for now. Cobham was founded by aviation pioneer Alan Cobham in 1934 as an air-to-air refueling specialist company, and it's still one of the major things that we do if you've ever seen air-to-air refueling on TV. It's an international company employing more than 11,000 people on 5 continents. We have 3 divisions: aerospace security, defense systems, mission systems. Chris and I are in the defense systems. We do all military work. We have an annual revenue of $3 billion. 60% of that comes from Cobham, USA. It is a UK-owned company, but the US does the bulk of the revenue. We have 38 plants, which I think are dwindling into, we're doing the standard operating framework. We're going to be shutting down plants and combining plants. They chose 14 principal manufacturing sites this past year, and our Lansdale location is one of them. So they will be bringing a lot more work into our plant. Quick background on me. This was not my first career. I was a baker. And then my father had a consulting firm. My father's a mechanical engineer. He had a consulting firm. He was an expert witness in vehicle and truck dynamics. His company got big enough where he needed someone to help him out. So I took the job. Who doesn't want to work for their dad? About 8 years into working for him, he looked at me one day and said, "You need to go back to school and get your engineering degree." He says, "You can't sign off on all the work you're doing because you don't have a degree." So I started back to school. Started at Westchester University just to do some general math and everything because I had a daughter who was still in elementary school. Then he was diagnosed with cancer and died in 3 months. I decided to honor his memory. I would continue on and get my degree. Got accepted to his alma mater, Drexel University, and graduated in 2002. 3rd generation in my family, first female. And graduated higher than all the males. So that's a little background. I did my co-op. I knew I wanted to do something in aerospace, love aircraft, love planes. So I picked a couple companies, did a couple interviews, and our company was actually called BAE Systems at that point. So I did my co-op there and was offered a job, I guess a month before I returned for my senior year at Drexel. So when I graduated, I already had a job. So that was one of the benefits of going to Drexel. I decided to choose 3 very, very different projects that I've worked on to give you just a little insight into some of the things we do. Not part of my daily stuff, just way out of bounds of stuff that I normally didn't really do. The first one was in 2006. BAE Systems was working on a cooperative avionics test bed for the F-35 with Northrop Grumman. It was Northrop Grumman, BAE Systems, Lockheed Martin, and the government. This is a actual 737 plane that we literally gutted, and all the JSF equipment is in there. This was one of the first of its kind that was done, and it basically is testing every system that's in the F-35 Joint Strike Fighter. All the EW, all the missions equipment, and it's basically to work out all the bugs and everything before the actual plane starts its mission. So the plane was retrofitted with the JSF 35 nose. I worked on the cockpit, actually. There's a whole F-35 cockpit behind the actual 737 cockpit. So I worked on that, and if you see the pod on the top, there's a bunch of antennas in that pod. So those were some of the things that I worked on while I was out there. Just totally really cool thing to do, not what I normally do. So the second thing, we were working on a proposal. BAE Systems bought United Defense Company, I think in 2005. We had 3 months to do this proposal, design a vehicle, and get a prototype built within like 6 months. We were working with, I think, 8 different BAE plants all over the United States. I got tasked with the front engine capsule. Now, I've never worked on this kind of vehicle. Everything I always did was aircraft, antennas, this kind of little stuff up here. Everything on this vehicle is 1/2-inch steel, welded. I mean, it's huge, just not in my bailiwick. What this does is this is pretty much used in the Iraq War and Afghanistan. It does searches for IEDs. There's robots in the back that they can send out on a mission. There's a gunner's turret on top, and the biggest problem with this vehicle is there's so many electronics in it that are running that the truck has to provide enough power to it, and they couldn't get the power they needed to run all the equipment, because when you're searching for IEDs, they scrape the ground and you're running at about 5 miles an hour. So they were running actually their batteries down, so they would actually die in the middle of the field. So if you want to go to the next slide. So this is pretty much what we do. The first step, we model it in CAD. We come up with a concept, we model it in CAD, and we normally have preliminary design reviews, go over everything, and then we go to the prototype phase. So this is an actual picture of the kit that would be used to on the engine, because they wanted to field this out in the field in Iraq. I literally had to design something that you could put in a box and take to a vehicle out in the field. I think the next slide, yeah. So the things we were looking for were vibration, belt slippage, you know, all that kind of stuff. And we were told by the manufacturers who actually put the engine together, it's Cummins engines. I was, I guess, stupid enough to not know that they like to use commercial off-the-shelf parts. Well, when I looked at it, when you're designing a pulley system, it's pretty much a pulley size dictates your RPM that you get out, which is your amps and your alternator. Well, they weren't big enough. So I'm like, okay, I need a new pulley. So I designed a custom pulley. They don't like custom stuff. They're like, you can't do that. I'm like, I'm not violating the law of physics. If this is what it requires, this is what you need to do. So they poo-pooed the whole way, said it's not going to work, so it worked. We won a $2.2 billion contract. I think it was 5 months by the time we were done prototyping everything. What happens when it actually goes off underneath the vehicle? So that's why I feel, you know, what I do is important, because we're saving lives out there. And everybody walked away from this IED. Everybody in the truck, every soldier walked away from that. So it's pretty, I mean, this right here is the axle of the car. The engine's over here. There's a wheel back there. We do electronic attack, electronic surveillance in our business, and I do a lot.